It is given that the tungsten filament of an electric lamp has a surface area A and power rating is P. If the emissivity of filament is sigma and epsilon, and sigma is the Stephen's constant, the steady temperature of filament will be. So we can say that the steady temperature means it is maintaining a constant temperature. That means the energy which is given into this one should be equal to the energy which is coming out. Energy is given in the form of electrical energy, and it is coming out in the form of radiation. And we know the equation for power due to like radiation, that is E sigma A, temperature of object raised to 4. So our aim is to find out the value of T over here. So we can just rearrange this equation. P divided by E sigma A is the value of T raised to 4. So according to this question, we can write as P divided by epsilon into sigma A, and we are taking raised to 1 by 4 on both the side. Over here raised to 1 by 4, and here also raised to 1 by 4. So we'll get as this raised to 1 by 4 is a value of T. So we are just rearranging the equation in terms of temperature.